Okay. We're going to start with 600 grams of this lead-210 sample and let it decay down to 1 gram. So our equation is time is equal to negative the half-life divided by the natural log of 2 times the natural log of our final concentration divided by our original concentration. And so I've got negative 22 minutes divided by the natural log of 2 times the natural log of 1 divided by 600. Let's see. Negative 22 divided by natural log of 2, close parentheses, times the natural log of 1 divided by 600, close parentheses, equals. So I get 203. I get 203 minutes. What's the way we could check that to make sure that the math looks good?
Divide 600 by 2.
No, that'd be 300.
And then keep doing
Eliminate
it.
through the table.
And keep doing it, right? Okay, sure. So like 600, 0, 300, 22, 150, 44, 75, 66, 88, I don't know, what is that, 35, 37 point and a half? Yeah. And then 110?
Yeah.
15, 16, 17, 18, 18.25. Yeah, that looks good. And then
75. Whatever it is.
Pretty close. You keep doing that, yeah.
all right, so I'll go with 9.4 and 1032, and then 4.7, 154, and it'll be 2.35 and 176. Yeah, that looks good to me. Very close.
Pretty close.
Okay, we should be fine. What is a nuclear decay series?
Series of which isotope decays into
Isotope releases different types of
eventually reaching a stable.
Okay. So just have a number of decays, nuclear decays, and then eventually I will find one that has the correct proton to neutron ratio. What is the part of the nuclear plant, or what's the function of the nuclear part of the electrical nuclear power plant?
to heat water.
That's it. The nuclear part is just to heat. Whoa. Stop. So in other nuclear power, or in other electrical generating plants, what do they use? Coal, wood, natural gas, garbage, tires. You can see all kinds of different things. So really just a super expensive water boiler. Okay, so fusion. What do we got with fusion? What is fusion? and what else? And lots of heat, right? So what's the byproduct besides the heat? Just helium. Just regular old helium. Anybody worried about that? No, it's just helium. No big deal. Second? We need it. We absolutely need it. We need helium. Why do we need helium? Okay, so
There's not, it was the element that wasn't found. Wasn't like missing.
We can't make it.
It was really hard, it's really hard to obtain.
mm,
That's the nice of it.
We fill our balloons with it, so you're happy for that.
all you need is some radioactive material, right? Because you have an alpha decay, and the moment the alpha decay comes out, then it just steals 2 electrons from something and helium. So as long as you have some nuclear stuff, you'll always have helium around. So the organization, who do you think controls the helium?
Whoever controls the nuclear stuff.
So who do you think controls the nuclear stuff? Federal government? Federal government's responsible for it. So there was a no balloons 2 summers ago. Anybody remember that?
Yeah, you're
There was a helium shortage. The helium shortage was caused by the Republican Congress deciding they didn't want to do anything that made it look like they were helping President Obama out in any way. So they just turned the government off. Problem is, well, the government is responsible for helium. So, okay, so having no balloons is a problem. What's the bigger problem? What? Yeah, but who cares?
Other practical uses.
Second?
I said some other practical use for it, but
Anybody know what the practical use is? I don't watch it, but I heard they talked about it on Big Bang Theory. No? Okay. So, yeah, an NMR is a particular analytical machine, and it runs off of incredibly cold magnets, and liquid helium is used. We actually lost several machines. Like universities lost $500,000 to $1 million+ machines because they ran out of liquid helium and the magnets warmed up to a temperature that made them not be able to be cooled back down and function. It wasn't a good thing. Okay. The reason we don't have very much helium on the planet, even though we've got a whole bunch of nuclear stuff, is it's so light that gravity can't hold it here. Then you might ask yourself, well, hydrogen's lighter. How come that hangs out?
attached to stuff.
It attaches to stuff. If there was just hydrogen, it would not stay, but it attaches to an oxygen molecule, and now I got water. Helium doesn't do anything, doesn't react with anything, which is why we never found it, and it just literally floats off. Every day, helium just leaves our atmosphere because there isn't anything keeping it here. So how come humans aren't using this nuclear fusion if all I get is helium and heat?
It was too much.
Yeah, too much heat.
Is there like cold fusion?
That is the goal. The issue is we haven't actually successfully done that. There was a terrible, like a little dark era in nuclear fusion, maybe 20 years ago, when 2 different schools in Utah who are both studying, trying to figure out cold fusion. And all cold fusion means is the fusion process happens at a temperature that we can manage. By cold, we mean like less than 20 billion degrees, kind of. Like, it's fine if it's, 10,000 degrees, we can hack that, but 20,000 or 20 million degrees, whatever it is, can't do that. So 2 schools, researchers thought they had figured it out, and they both freaked out and thought the other one was going to publish first. So they both published, one in Time and one in Newsweek. Time and Newsweek aren't really science journals, and so they were hailed as like saviors of the world until their data came out and people did the math and said, hey, you did the math wrong. This didn't actually happen. So we don't have it. We are working really hard at regular fusion, and the thing that we use to contain the reaction are magnetic bottles. So we have incredibly powerful magnets that create these little force fields where this stuff happens inside of. So it's not just hydrogen, it's deuterium, because the reaction is actually 2,1H plus 2,1H yields 4,2. So there's deuterium, meaning it's not just regular old hydrogen, it's a hydrogen with its proton and one neutron. So not a super usual hydrogen. But those two things come together and make regular old everyday helium. What was I saying?
Cold fusion.
Cold fusion. We're trying to do this. Oh,
Force field.
yeah, we have a force field that holds these things into a container and squishes them together. The problem is it heats up so much that the magnetic bottle that gets created, the magnets start to overheat that are creating that bottle, and so we still don't have it. We're not really sure. Basically, we would like to make a tiny, tiny, tiny sun inside of a facility. That's our goal. Because that's literally what it is. The sun is just deuterium squished together to make helium. At least our sun is. Other suns past their prime use other stuff. Okay, so did we look this one up? All right, so when you
Is it just really well built?
no, I mean yes, true. I mean that's definitely part of it.
Leak-proof building for containment buildings.
It's a really nice beach. Do you think people hang out there? Why not? Because there's an operating nuclear power plant like 20 feet from you, so it's not the most inhabited beach in California, that's for sure. What question did I ask? Yeah, why is the NRC not all worried about this? Is radiation leaking into the ocean? No,
It's all contained.
it's all contained. So would they know if anything was leaking into the ocean? Why?
Because there have to be.
We have a lot of
Alarms.
problems there.
Yeah, there's, multiple loops with alarms and I still don't think it's a very good place for it to be. Why did they build it there? You need cold water source, a constant cold water source. I still think they should have moved in 20 miles, 10 miles, 5 miles even. I mean, the whole reason that Fukushima went is because it got hit with a tidal wave, and there's no reason why this couldn't, because it's not like California is devoid of seismic activity. It's very possible, so probably not the best place.
It says built to withstand a 7.
It is built to withstand 7, but what happens when it gets hit with 8? Superman 1? Yeah, something like that. Okay, so imagine my surprise when I was reading the newspaper and I came across this article. What's wrong with this?
Nuclear as a supporter, at least.
Yeah, okay, this thing, no. Two big chunks. 3 neutrons. Les Mittner, element 109. Which one is it? Is it 109? Right after hafnium? Can't see 6, 7. No, maybe not. What is that? MT. Mitrium. Yeah. Which one is it? 109? Yeah. Element 109 is named after the woman who came up with this. And this is BS. This would be freaking awesome. Why? If this actually happened in nuclear fission.
Because we use fission.
We do use fission. Absolutely. That's what we use right now. Why would this, if this picture actually was the true scenario of what happens during nuclear fission, why would that be great?
You can only make one. Out of one, you would create many more, and then more.
What am I creating when that, when from this picture, when that uranium gets blasted apart, what's it get turned into?
A bunch of other metal things.
What things specifically?
Is that
What specific?
Neutrons.
Protons and neutrons, right? A bunch of neutrons that would be absorbed by the shielding and a bunch of hydrogen. Are we worried about that? And the whole problem with nuclear fission is having a bunch of waste products. There aren't any waste products with this. This woman is a genius. She just figured out a way to not worry about waste products, except it's not true, right? These two big chunks are radioactive for a very, very long time. So no, this doesn't exist. What's wrong with this? What's wrong with this picture? A smaller release of energy, really? Because if that was the case, we'd be using the hell out of it. It is not a smaller release of energy. It is an incredibly large amount of energy. Plus, it says that that's an alpha particle. That right there is not an alpha particle. An alpha particle is 2 protons and 2 neutrons. That is a tritium. That is one proton and 2 neutrons. Or wait, no, sorry, that's 2 protons and 1 neutron. Can't exist. Isotope wouldn't handle that. So I called UCLA, because that's what this says, University of California Physics Department, and I asked for the physics department, and they said, we don't have a physics department. Really? Because I got an article here that's got a picture that cited the physics department of UCLA, and they said, we don't have one. We have a science department. I'm like, okay, can you send me to the chair? I get the chair and I say, hey, yeah, so I'm just reading this article that's got a bunch of bad graphics, and it says it's from UCLA's physics department. We don't have a physics department. I just found that out. So, and I told them where to look. Do you guys know what the Associated Press is? Do you know what this is? The Associated Press is a news organization that basically certifies a journalist to submit articles to them. So you can present your work to the Associated Press, and if they decide that you're qualified, that you produce good work, they'll give you a certification, a credential as an Associated Press news reporter, which means you don't work for the Oregonian or work for the LA Times. I am a journalist, and I can go out and do stuff, and when I write stuff, I submit it to the Associated Press, and the Associated Press puts it on a wire service. And the wire service, anybody can read it. And if I'm, say, the Oregonian, and it's June 28th of 2005, and I have a hole in my paper, I don't have a spot to put an article in there, I can go to the Associated Press, find something of the appropriate size that I think is interesting, and plug it right on in there. So when you see an Associated Press article, that just means any old person that they certified wrote it, and you're reading their work. So this woman that wrote this article, she didn't know what she was doing. She didn't cite her source. The source that she cited is totally incorrect. When the department chair of UCLA found this article, he sort of had a little conniption, and the two of us both tried to get a hold of the Associated Press to make sure this woman didn't write any more science articles, but they weren't exactly very helpful. And then I sent a letter to the editor of the Oregonian saying, you failed. When you read an Associated Press article, it's not completely vetted, and you're supposed to vet it. Both you and your science editor didn't vet it, and you need to, because this is an important topic, and you're disseminating information that's incorrect. Also didn't seem to care all that much. So I was kind of sad about that.